Hello, everyone. That's Alex VOLOCHNEV and Erick RAMIREZ, developer advocates at DataStax. And today we are going to speak about creating an efficient data model for highly loaded applications working with Apache Cassandra. Hi, Erick.
Hi, Alex. Hello, everyone. How you going?
Yeah, very well. I'm really happy to be here today. I see a lot of people at the channel, and that's makes me really happy.
Nice. So just give us a thumbs up if you can hear us perfectly.
Yeah. So if you hear, if you see, please thumbs up and we will start.
So just
Okay.
doing a sound check and a video check. So just checking that they're all in sync.
Yes. And great. I see a lot of thumbs up. Incredible. So let us start. First of all, I want to say we have a lot of people at this workshop series, and that's incredible. We have more than 10,000 registrations for this set, and that's just great. So a lot of people want to be better developers and work with great technologies. Very good. And what you see at the screen, that's a stadium, that's like 10,000 people at one place. Well, we are spread it all over the world. For example, I'm now located in Germany. And Erick, where are you located?
Melbourne, Australia.
Yeah, so you see, we are really globally distributed, as Cassandra Doom. So let's go on. Of course, there are not only two guys delivering this workshop, but the whole developer advocacy special unit of DataStax. So there are a lot of people answering your questions in Discord and YouTube chat, preparing materials, and all the things you need to do to be successful with this workshop series. What we do today, it's a week 2 data modeling for Apache Cassandra. I hope you attended the course, you attended the last week, getting started with Cassandra, Cassandra Fundamentals. If you didn't, that's very fine. Everything is recorded and you can do your homework in any time. So don't worry, you're still on time. And you know what? If you have some friends who want to be a better developers and work with great technologies, then call them now because, well, it's a great time to start.
Let's go.
Yeah. So how does it work? Attend one of 2 live streamed workshops Wednesday and Thursday. They are the same, maybe different speakers, but they're the same content. So please choose one what matches your time zone better. During the workshop, you may need following things. First, live stream. If you're watching me right now, mostly probably you are doing it at YouTube, but we also have a backup channel at Twitch. So if you prefer Twitch, you can watch us there, but we do not answer questions on Twitch because, well, we cannot be everywhere. Not so big team. Then the main place to ask questions, which will be available even then a workshop is done and over, is Discord. Discord is the best place to communicate live. Then we do quizzes with menti.com. And first quiz starts very soon. To do all the exercises and work with Cassandra, we use DataStax Astra, Cassandra as a service. It's a great tool because, well, Cassandra is a great database, but it also has a lot of things to do if you want to deploy it and make it running. So what DataStax does, we run Cassandra as a service, and you can start working with Cassandra without really deploying that, which saves you a lot of time, trust me. Then materials are available at github.com, DataStax Academy, Cassandra Workshop Series. You will have to download notebooks from there to do your exercises. And starting next week, we will do a live coding using Gitpod, but well, not for that week. Do your homeworks, and that's important. Homeworks are essential part of the workshop series, and you may need some help. That's perfectly fine. First, forum, community.datastacks.com. The greatest guy taking care of the community.datastacks.com is Erick RAMIREZ, sitting next to me, but in Melbourne, on the exactly opposite side of the world.
Thanks, Alex.
Yeah. We also, as said, we are using Discord, so that's a good place to communicate. And academy.datastacks.com, it's the place with our online courses. You will have to watch one as a part of a homework for this week. And to validate your presence and your homework, you will have to fill a Google form to confirm your presence. And
yeah, so Peter just pointed out that we're in complete lockdown in Melbourne. So yeah, thanks, Pete.
Good. So what we cover today. Today we will take care of everything relates to data modeling, and that's very, very, very important workshop and very important part of the workshop series. The point is, if you are, what Cassandra brings great features, all the reliability, highest performance, and so on and so forth. But if you do your data model wrong, you can ruin everything. And in this workshop, we show you how to be successful with Cassandra and how to really do your job great with Cassandra, so everything flies and everything available all the time. In the beginning, we will say a little bit of the key spaces, tables, and partitions, and why it's so important. When we design a data model based on the real-life example, so you see how it works, we talk a little bit about the data types, and well, that's the plan for today. And now for the beginning, we want to start with Menti because we have to ask you some questions. Menti code for today, 719518. I repeat, 719518. And we are going to start. I will give you some time to join.
Yep, so 719518. We'll have some of our guys bringing that up too. And yes, Craig, I never do sleep.
Yeah, Erick RAMIREZ is well known in DataStax because he never sleeps. He is available at the community and our Slack channel all the time. Well, what's your secret, Erick? Tell us. How do you never sleep? Why are you always online?
I've got robots working in the background answering questions for me.
Okay, I see. So you have a great team working with you. Good. Okay.
So do Menti on your mobile. It's a lot quicker if you want to answer quickly. So there's less lag.
Yep. Oh, Sasha Torres. Sorry, I was in Menti yesterday, so I don't go this day. Sasha, thank you so much. And yes, that's fair play. Thank you so much. Regarding the Slack channel, well, Slack channel, that's internal DataStax channel. If you want to join internal DataStax channel, you have to be hired first. But we are hiring, and I see a lot of great people at these workshops, so it makes sense to apply if there is a currently open position what fits your skills. Good. So let's go. First, regarding the last week, please answer. First, we want to know, did you homework or not? And then you joined it the last week or this week first time? Interesting numbers. So most of the people attended week 1 workshop live and did the homework, but there are also some new people. Some people joined it today for the first time, and some people watched.
Welcome.
Yeah, welcome. And some people watched week first afterward on YouTube. Well, okay, of course, that's smart. And you can watch those workshops anytime you want. For people who joined it today for the first time, of course, great, welcome. But we do recommend to watch the first workshop as well, because where we are talking about the fundamentals of Cassandra, and it's a really important workshop. Now, there are some people who didn't do the homework. That's perfectly fine. That's a more or less self-paced course, so you can do homework later. There are no strict deadlines, so don't worry, but just do it, please. Good. Now, I see almost all people join at the Menti. Thank you. Good. For those who did the homework from week 1, was it too much? Was homework practical enough? And was the validation form easy or not? Okay. Most of the people think it wasn't too much work. So we have to give them more homework, you see? Homework was practical enough. Great. That looks good. Validation form is mostly easy, also good.
And we do have a lot of people asking what the answers are to the validation form. We'll be providing that in the next mail out. Those asking for the code on Mentimeter, it's right up there, 719518.
Eric? Okay, now, very interesting question for us. What are your plans for Apache Cassandra? Are you using it right now or planning to use in one of the upcoming projects, or you don't have any particular plans? I can say what both answers are perfectly fine. Of course, we are happy to see Cassandra usage growing, but anyway, if you learn a new database, you understand which use cases it fits, it's make you a better developer and be better able to design and architect your systems. So that's great anyway. Now, what's your experience with SQL and relational databases? Example of this week is based in the comparison with SQL and relational databases. So of course, it's easier for you. It will be easier for you if you know relational databases, but nothing serious and nothing too deep. So if you aren't expert, don't worry. Our examples are very simple and designed to be a good fit for beginners as well. Good. So I see a lot of answers. Nearly everyone knows what's the SQL and relational databases. And that's great. That makes our work a little bit easier today. Good. And the last question about normalization and denormalization. Do you know what is it? Do you use it? Do you understand how it works or not? Don't worry if you don't. Still, we explain everything needed, but that's interesting for us to understand how high pressure for you is created by those courses, if we maybe have to simplify something.
And so here we go, Alex. We keep getting asked about the vouchers again. So just letting you know, everyone else know. So towards the end of the 8 weeks, you'll get the links to register for the vouchers. So you just got to hang in there.
And don't worry, no one who attended our workshops never quit without voucher, because, well, we want you to grow and grow your skills and be successful. And of course, certification is an important part of this process. Okay. So I see most of people know normal forms and understand normalization and denormalization in general. And a lot of people also not so strong with that. Again, don't worry. So I will spend some time on it and explain what is it, how it works, and why it's important. So thank you for answering our questions. And now let's start the real part. We start with key spaces, tables, and partitions. So in the beginning, first, let's walk a little bit through the Important terminology and what is it what, as we did last workshop. 2 words about infrastructure, very briefly. It's everything starts with a server. Everything starts with a running Cassandra node. And this node can be a bare metal server, a virtual instance, or a Docker container. It doesn't matter for us. It's still operational Cassandra node. Nodes are grouping together into a data center. Usually, those nodes are located in the same physical location, like a regular data center. You have a bunch of servers running there, but also it can be a cloud data center on, let's say, AWS or Google Compute Platform, or it can be some virtual nodes located in the same availability zones. And then in the end, those data centers are united into a cluster. You may have only one data center, or you may have multiple with them, a lot of them, doesn't matter. Cluster can be of a single data center or of a lot of them. And then we go to data structure. And data structure starts with a cell. Well, I hope everyone understands what the cell is. It's an intersect of row and a column. It stores some data. That's the base of any table. And a set of cells, a single data item of a table makes a row. And you may ask me, Alex, why are you explaining us about the cells and rows? Okay, come on, nearly everyone has experience with SQL. We know rows, we know cells, we know columns. And I tell you, here comes some difference. So I want to start to the beginning. When you work with relational databases, and you want to access some information, and you do select something from table name, where, statement, and all the things, you work with the database, table, and then rows. In Cassandra, we have one additional base unit of access. Very important thing, partition. What is it, partition? Why other databases don't have partition? And why Cassandra needs that? I explain. You see, when you work with relational database, like let's say MySQL, for example, as long as your data fits into a single machine and you don't want this data to be distributed over multiple nodes, it all goes very fine. But then comes the situation what you may have too much data, or you want to spread data over multiple servers, and you do sharding. And it's wrong to think what our databases don't have partitions, because, well, they have shards which created to solve the same problem, but in, well, very, maybe not the best way, not comfortable for the developers, because sharding is a pretty painful process. So don't forget, Cassandra was designed to work, to be big data native from the very beginning. And it means we know we are going to work with the data which will not fit into a single machine. In this way, every table is split into the partitions, and those partitions are spread all over the world to your nodes to keep the data. Then, if we want to split table into some partitions and distribute them natively, we need somehow to decide how do we split them. To make an easy split of the partition, we can do very simple thing. We need to specify a partition key, some column or set of columns. Those values will define partitions. So columns with so rows with the same property of this column will be stored within the same partition. In this case, you see at the screen a partition of some people from wizardry department, and obviously they are stored together in the same partition. That's important to understand. All of the rows of these partitions stored together. That's important, and I will explain you why in some seconds. Well, in some minutes.
So Alex, we've just got a few requests here, so if you can just make our heads a little bit smaller, because
yes,
we're covering some of the slides.
Thank you, sir.
And while you're doing that, so one of the common questions, and it was asked in the earlier session as well, so what is sharding? So sharding is when you split the data and you distribute it across different servers in your cluster. So it's not a Cassandra terminology, but it's just you could have like a MySQL database that all your data doesn't fit on just one server. So you might decide to shard, for example, all the data for Monday will be on server 1, all the data for Tuesday will be on server 2. It's just a way of splitting the data.
Mm-hmm. Yep. And yeah, that's actually important to notice. Yes, because a lot of developers are lucky enough to never meet the sharding in real life. The point is, well, the data is not fit to a single machine and you have to spread it over multiple machines. For relational databases, it's a non-native process, so it has to be done manually, and resharding has to be done manually. If you add a new node, you have to reshard data. It has to be done manually, and there is really a lot of work. And at this point, you lost a lot of benefits delivered by relational databases.
And that's a really good point, Alex, because in Cassandra, instead, we don't do sharding. And again, but like Alex said, it's because you're manually managing it. Instead, in Cassandra, we do partitioning. We partition the data and the data gets automatically distributed around the cluster. And the way that the distribution happens, if you add nodes or if you remove nodes from the cluster, Cassandra will automatically balance the data for you.
Yeah, that's a very important notice. As an operations guy, I really like how Cassandra takes care of me. If I add a new node, that's for Cassandra to repartition the data. If I decommission a node, that's for Cassandra to repartition the data. And that's just great. So let's move on. As you told me, I made our faces a little bit smaller. So now we will not hide the important data. Thank you. Now, key space. There were a lot of questions. What's the key space? Key space is a group of tables sharing replication strategy, replication factor, and other properties. Consider key space as a container for tables.
So what's the equivalent, like namespace?
We can say it's a namespace or a database by itself. Yeah, like that. Good. So if you want to see the overall view on the data structure, key space is a container for tables. Tables are containers for the partitions. Partitions store data having rows and columns. And working with real data, so you can see at the screen, users by city. It's a list of the users. And as you see, we're having two partitions here, Phoenix and Seattle. And I guess you understand already what city in this case works as a partition key column. So value of this column will be used to partition data. And last name and first name are clustering columns. I explain it in a minute. And address and email are data columns. When we create a key space in Cassandra query language, creation process looks very simple. We create key space, define the key space name, and specify some properties. There are a lot of properties for every key space, but that's not a maintenance and operations course, so I will not do a too deep dive. Then you define a key space, you must specify only two properties, replication strategy and replication factor. Replication strategy defines how the data will be allocated within the cluster. In our case, we talk only about the network topology strategy because you want your Cassandra to be smart and understand where's which the data center, what the server rack, and so on. And then replication factor, you specify per data center. So if you have multiple data centers and you want your data to be available on multiple data centers over the world, then you specify replication factor per data center. In this case, I want this key space to be allocated for 2 data centers. I may have more, but this one I want to be allocated for 2 data centers, and I will have replication factor free in United States West 1 data center, and replication factor also free in Europe Central 1, which is obviously going to be Frankfurt. Good. And then I create table in Cassandra query language. I first have to arrange a key space for this table, because table cannot exist without the key space. So I say my key space will be users, which I just created, and tables. Table will be users by city, having some column definitions: city, last name, first name, address, emails. They are all texts. And then interesting thing comes: primary key, partition key, clustering column. What is it? Why it's important and how it works? Primary key have 2 duties. First duty is it must ensure uniqueness. In some databases, you may be used to have some sequential IDs, for example, when you ask your database to create an ID for an entity for you, and you have some sequential IDs. It's great idea as long as you have maybe 1 or 2 servers, but when you are getting ready to work with maybe dozens of thousands of servers, then trying to generate a sequenced ID obviously may take some seconds to communicate within all the servers if this ID is already taken or not. So we don't use IDs like that. Primary key is something what uniquely identifies a row, and you can specify which columns go for this definition. So, good example of a primary key: city, last name, first name, email, for example. And bad example for the primary key is city, last name, first name. Why this is a bad example? Eric, how do you think why it's a bad example?
Well, because it's, you'll have lots of entries that for city, and you'll have lots of last names, for example, lots of different people belong in the city.
Yep.
Think of a city like New York, where you have millions of people.
Yeah, definitely. And about the big partitions, we talk in a couple of slides later. Yeah, big partitions may be a big troublemakers also. And in our case, also, this primary key doesn't ensure uniqueness, as I guess in the same New York, you may have a couple of dozens of John Smiths, and every next John Smith will not be happy when other John Smith will overwrite his data. So primary key must ensure uniqueness. But the second duty of primary key, it also may define sorting. And that's sorting done with clustering columns, and it's really great. So then I tell about clustering columns after a couple of slides. Now, very important thing. Partition key is a part of a primary key, and it's identifier for a partition. And that's very, very, very important thing. It partitions rows. It's very important to be very careful with partitions, because if you do your partitioning wrong, then it makes cluster work very slow. And what's the example of a good partition? Take a look. Primary key consisting only of a user ID. What does that mean? It means what the user ID, universally unique ID, will work as the partition key and primary key at the same time. It's perfectly fine. It means what, as every user has unique ID, and your primary key and partition key is the same, it's very fine, because you will have as much partitions as users, and it's okay because you can have as much partitions as you want. Don't worry about that too much. But second example, primary key consisting of the video ID and comment ID. I'm talking about comments to a video. Imagine you are watching YouTube and you open a video page and you see the video and read some comments. Well, some comments at YouTube are not so useful, but we are speaking about partitioning. So in this case, we partition comments by video ID. It means what all the comments will be stored for a video will be stored within the same partition, and that's very good for us. So we open a video and we can load all the comments for this video within a single query to a single server. And bad example given downside with sensor ID and logget add. Well, I will explain in a minute specifically. Now, clustering columns. Clustering columns is a part of the...
Can we just quickly go back,
Yep.
Alex, because
Yep.
There's a lot of confusion and lots of people are asking.
Don't worry.
So if you just go back to that slide. So in the very first example where the primary key is the user ID, what you see there is that the primary key only has a partition key. It doesn't have any clustering columns. So it means that you're accessing the table just by the user ID, and then you might have like username, mobile number, email address in that table. In the second example, where you've got the video ID in a bracket, it means that video ID on its own is a partition key, and then the comment ID is a clustering key. So what does that really mean when we say, it's a clustering key? It means that, say, for a videos, let's give an example where you have the movie Mission Impossible. Because you have the comment ID as a clustering key, it means that we have lots of rows of comments associated with a video ID. And the video ID being the partition keys, what determines where that partition, the whole partition, gets stored around the cluster, how it gets distributed around the cluster.
Yep. Okay, don't worry, I making a deeper dive in a couple of slides into the partition, because partitions are important. Good. Clustering columns use it to ensure uniqueness and sorting order, and they are optional. You may have them or may not, depending on your requirements. In the example with users by city, last name, first name, and email are clustering columns. And last name, first name added there for sorting purposes, and email is added for the uniqueness purposes. So if you see it, the first example is wrong because it's not unique. Primary key is not unique. And in the second example, it's good because, well, we added email, and we hope every citizen of New York has unique email. And in second case, first primary key will work. Video ID and comment ID. We can retrieve comments having video ID. And but that's not perfect scenario. If you attended the last workshop, you remember what on the right path, everything is pre-sorted in memory very quickly. So when you fetch the data, Cassandra doesn't have to sort it, and you don't have to sort it. And that's great because it saves you a lot of time. And that's done and ensured by clustering columns. So if you have, in the last example, created as a clustering column, when all the comments will be sorted by the creation time, and then you retrieve comments, they will be sorted by time already, and you don't have to worry about that. Now, deeper to the partitions. How partition work? So take a look. Every node is responsible for a range of tokens. So we have, for example, let's say we have 100 range and 10 nodes. It means what first node will be responsible for a token range of 0 to 9. Second will be responsible for the token range 10 to 19, and so on. So all the ranges are covered by all the nodes. If you add a new node, ranges will be recalculated, and some of the ranges will become the responsibility of a newly added node. When you remove the node, obviously token ranges are recalculated again and data moved, but that's a responsibility of the cluster, so you don't have to take care of that, and that's amazing. So every node is responsible for a range of tokens. Then you insert a new row, create some data. We calculate the value of its partition key, hashing it using murmur-free hasher. What does that mean? So take a look. In this case, city is our partition key. And when you're inserting some data, you must specify the city value because you cannot create data. Partition key cannot be null. It cannot be empty. You always have to give some data there. Let's say we have a city Seattle, and its hashed value becomes this long number 24667171130, and Seattle is the partition key for this row, and partition token is this long number. I don't want to read it again. It means what this partition, this row belongs to a partition, and this partition belongs to the nodes responsible for this token. In my example, I'm speaking about replication factor 1, but obviously, usually you're going to use replication factor 3 or higher maybe. So it means what multiple nodes will be responsible, replica nodes will be responsible for this number. And therefore, sorry, last phrase, the insert query goes to the node storing this partition. Yes, Eric?
Yeah, so I was just going to quickly explain again because we keep getting the same question. So if you attended the first workshop, then these are the stuff that we talked about in terms of how the data gets partitioned across the different nodes. If you haven't, you need to go and watch the videos in the DS201 Academy course. The details are in the links that get provided where all the materials are. But just really quickly, so the question was, how does the token, like how do you get the token? The token is a hash function from the partitioner. The default partitioner that we use in Cassandra is the Murmur3 partitioner. It's a hashing algorithm. It's not a Cassandra algorithm. It's a mathematical algorithm that Cassandra uses. It just and it's called Murmur3. When we hash the value of the partition key, so in the example here, the value of the partition key, not the primary key, just the partition key, which is the city, the value Seattle, when we hash it, we get a specific token value for it. And that token value determines where in the cluster the data will get stored, on which node the data will get stored.
Yep. And this job is being done very often with your driver or with nodes. For example, when you are trying to retrieve a data from a node, so you want to read something, you want to find all the users of the city Seattle, and you write a select statement, select everything, well, bad idea, but still select everything from users by city, where city equals Seattle. What happens then on your driver? That's a much more interesting process than you may think, because it begins much earlier when you do a statement. As your application starts, drivers can connect to the cluster and read them, retrieve all the situation on the cluster, which node is responsible for which token ranges. Then you do your select statement. We calculate with this Murmur3, we calculate token for this partition, token for this city. And we take this token and we already know token ranges. So which node is responsible for which token, set of tokens. And when we know which particular node to ask. So as you remember, every node is a coordinator node. Every node is able to dispatch any request or at least redirect it to a proper nodes. But we want to avoid additional network steps as we want to be as quick as possible. Therefore, already driver knows which node to ask, and driver goes directly to the node, keeping these data to be as fast as possible.
And yeah, so a lot of people are asking questions that are covered in last week and the DS201 course, so you need to look into that. But one of the really common questions, Alex, is what if we want to change the primary key? And this is a really important point, so I hope everyone's listening. You cannot change the primary key of a table because the data is already stored in the cluster. If so it's not possible to change the primary key, because if you do, you can no longer retrieve the data that you've already stored. That's really important because the way that the data is stored depends on how the partition key gets hashed. And if you change that, then the data's gone.
Yep. The point is primary key, both partition key and clustering columns, are defining them not only some properties of the table, but they also define a really physical storage for all the data. And again, that's Cassandra. You have to be ready to work with the big data. It means petabytes of data, maybe dozens petabytes. And therefore, well, then if you want to change anything like partition key or clustering column, it may lead to basically tremendous amount of work to do within your cluster. Like basically it has to rewrite every row of the data. It's just not a best practice. It's a great way to paralyze your database for maybe days. And we don't want it. So if you want to change anything within primary key, you will have to create a new table and migrate your data. Okay, so rules of a good partition. And if you see a warning at the top right, the slide of a year award, yes, I do think that those next slides may really, they define a line which prevents you from being successful and efficient with Cassandra. Learn that, and you will always understand how to design your data model to be successful and efficient on any amounts of data. That's very important. That's the most important slides of the presentation. So there are three main rules of a good partition. Store together what you retrieve together, avoid big partitions, avoid hot partitions. First, store together what you retrieve together. Very simple explanation. If everything you want to load, store it within the same partition, then it's stored together on a single server. And then your query will be very simple and very fast. Get me this, and you got answer from a single server, and you have everything you need. If the data you want to load are spread over multiple partitions, there will be multiple queries to different servers, and obviously it may take time. Longer time than just a simple request. So we always try to store together what we retrieve together. In the first example, you have, that's our example of comments of a video. So you have a table storing comments for some videos. We have video ID as a partition key and created that and comment ID as a clustering columns. Let's take a look. Comment ID, we need everything to be unique, because same video may have some comments created at the same time. It's a rare case, but it may happen. So we need comment ID to ensure uniqueness. Created at, we need to ensure sorting order, so we will retrieve all the comments latest first. And video ID is our partition key. And that's pretty good partition key. Following this rule, store together what you retrieve together. So when someone goes to YouTube and open a video like you are doing right now, if you watch us, mostly probably you are doing it with YouTube, you may see some comments. You open a video, you get all the comments stored together. You don't have to ask multiple partitions and therefore multiple servers. And that's done with one single select statement and very quickly, because one server is able to dispatch the response. And a second example, well, is not so good. Like we are not having video ID here, so we cannot load everything, and we need to find another way to retrieve data from multiple partitions. It's obviously going to be much slower. Store together what you retrieve together. Then avoid big partitions. Oh, here is a great story. So take a look. Partition is something stored together. You remember why we needed partition? Because we want to work with any amounts of data, even tremendously huge amounts of data, petabytes, 100 petabytes, maybe zettabytes one day. And if we partition the data, we spread this data over multiple servers, it's good. But then if our partitions are too big, that again may happen what our data is too big for a single server. And there comes the problem. So there are no really strict limitations like technical limitations. But at some point, you may get troubles with maintaining the cluster because, for example, your partitions will be too big and then compaction cannot work. And when your cluster may stuck at some point. And your administrators, operators responsible for the cluster maintenance will be very unhappy and angry to one who created too big partition. So we recommend, that's about the size. So for example, limitation around 100,000 rows in a partition, that's very, very, very approximate. I would better watch to the size of the partition. Like we tend to have it like around 100 megabytes per partition, avoiding it growing higher. But again, it depends on your hardware and your use case. So it's important to not to avoid big partitions. But what's even more important is explained here. Let's take a look.
Yeah, because that gets asked quite a fair bit. So just quickly, so just don't confuse the 100,000 rows per partition. So you can have a limitless number of partitions in a Cassandra cluster. It's impossible. I can guarantee that it's impossible for you to have way too much partitions in your cluster. It's trillions and trillions of possible token values that you can have. But in terms of the number of rows, so in each partition, you try and have less than 100,000 rows, because then, by the time that you iterate over those rows, meaning that when you're reading one partition with, 100,000 rows, your query might time out, or by the time you process it in your application, it's too long. So think of things like, for example, if you had a social media application where you have a person that's way too popular. So for example, your partition stores the friends of a certain person. So someone like Kim Kardashian, there's too many people that follow her profile, for example. So you need to account for that in your application, in your data model.
Yep. And so take a look. Speaking about the big partitions, video and comments. I especially check it, making myself ready for this workshop. I especially check it. What's the biggest amount of comments per video at YouTube? That's interesting, by the way. Biggest amount of comments at this point of time has this video, Gangnam Style video. Maybe, this Psy Korean guy. And it's around 5 million rows, 5 million comments. And you may say like, okay, that cannot be a single partition because 5 million is obviously higher than 100,000 rows. Yes and no, because the main consideration here is the size, and comment is a small entity, like how much data is stored within one comment. You have user ID, maybe username, denormalization, so you have username, comment text, video ID. Comment ID. That's all very small values. So therefore, for those 5 million of comments are not too big. They're definitely as short string values. So it's not a big problem to have like 5 million comments within the same partition. So I see one gentleman asked a really good question at YouTube. Digvijay Singla. It's good for us to understand if you show partition key having multiple column example. Don't worry, I am exactly on that. So let's move on. And I told you to avoid big partitions, but there is a thing to avoid even more. Let's take a look at the example of IoT, Internet of Things. Huge Internet of Things in infrastructure, hardware all over the world. Different sensors reporting their state every 10 seconds. Every sensor in the report specifies its universally unique ID, timestamp, when it happened, and the sensor's value. So let's say sensor ID, UUID, timestamp is a timestamp, and value is, well, float or integer, doesn't matter for our example. And I have to design a data model for this use case. And I say, okay, store together what you retrieve together, and I retrieve together value of the sensor over the time. So I want to see how it was changing in the last month, for example. So I will partition it by sensor ID. All the reports of a sensor will be stored within the same partition. And my primary key will be sensor ID and reported at. So they will be unique and sorted by time. Great. And in the beginning, this approach works perfectly well and everything is fine and everyone is happy. But when a problem comes and something happens and my database doesn't working so good and operations guys are coming to me and hitting me with some coffee mugs and saying I'm a bad guy. So why I'm a bad guy and what's wrong with this data model? Just stop for a moment and try to think what's wrong with this data model, because something is definitely wrong. Eric, how do you think? How much time I should give to find out the answer?
Give them a few more seconds.
Okay, yes, because it's pretty simple one. First attempt, too much partitions, I see. No, you may have as much partitions as you want. There are no limitation. Huge number of rows per partition. Partitions will be too big. Yes, I see the correct answers already. In the beginning, partitions will be fine. But don't forget, every sensor reports its state every 10 seconds. When over the months, or if over 1 month already, it will be around 260,000 of rows per partition, which is getting maybe too big already. And then over multiple months, it become higher and higher and higher endlessly. So let's take a look what we could do to improve the situation. Oops. We have to avoid constantly growing partitions. How do we do that? There is a great way to handle this problem called bucketing. And well, bucketing is a very simple concept. We can introduce multiple partitions instead of one, having composite partition key. What does that mean? It means what we have not a single partition key like sensor ID, but sensor ID and something. And when as this value, second value changes, hashed value, so partition token, will be different, and therefore it will be another partition as soon as we change this second value. Do you know the salt? Like when you hashing your password, you don't want to just hash your password because it makes it more vulnerable for some kinds of attacks. So you add some salt, and hashed value will be different. That's exactly the same idea. You add something, and that makes hashed value different, and we have a new bucket. Bucket is kinda a sub-partition. So, well, technically it's a different partition, a new one, but the idea is the same. So, and now you can have like 15 seconds to think. Hey, given I have not so much data, sensor ID, timestamp, and value, and we need something to add to partition key. What should we add to the partition key to enable bucketing? Something like a number related to the month, year. Yeah, great. So, take a look. Exactly. I don't have too much data, so it's really easy to decide what to use. In my case, I suggest to use month, year, synthetical value. It can be a string or integer, doesn't matter, to enable bucketing. So take a look. Sensor ID per sensor doesn't change. Month, year, what does that mean? Month, year is, in this case, as it's July of year 2012, such a year, it will be equal to 072020. Why? Because it's a 7 month, 7th month of year 2020, 07 to 0 to 0. And it makes my partition key sensor ID, never changes for a sensor, and month year. And month is changing every 30 days. It means what as soon as July will be over and August starts, this value, month year, will become 08 to 0 to 0, and therefore hashed value will be different already. And what does it bring to us? At the point month changes, we create a new partition, or well, Cassandra creates a new partition for us, and we start to write to a new partition, and we never write anything to the old partition. It makes every partition of the size of approximately 260,000 rows, and that's not a big deal because, well, every row is very small, like we are storing only UUID, string, timestamp, float, so it's not too much data, and they are not too big. And that's a perfect example of a composite partition key. Eric?
Exactly, yeah. So, yeah, because that's being asked right now. So for those who are paying attention, there are two columns now in the partition key. And as Bettina answered in the questions, that's an example of a composite partition key because it's composed of multiple columns.
Mm-hmm.
And again, it's enclosed in a bracket inside the primary key.
Yep. I see some questions I want to answer. Really great questions at YouTube. Why not date or day, month, year, etc.? I will explain it in a couple of slides, but I want to answer it now. Take a look. We have to always specify partition key when we do a select statement because we need to know which node to ask. And therefore, if you have too specific time, like the day, month, year, then you are going to load data for multiple days, like for the whole month. Imagine your query. Select everything from data from table where sensor ID is and date, month, year is that or that or that or that or that or that or that. And now imagine you are trying to load data for a year. You will have to specify 365 possible keys. So that's why we think of the month year to be not too specific, otherwise it will be hard to load the data. I explain it in a couple of slides in a bit better details. So we don't use date or day, month, year because it's too specific and it will be hard to load data. Then, do I have to add month, year in a row? Yes, it will be the fourth row for this table because if you don't have it as a row and column, therefore you cannot use it as a partition key. Very simple. Good. I hope I've answered it. Good. Then, oops. So avoid big partitions, avoid growing partitions, now avoid hot partitions. What does that mean? Take a look. That's one of the very important things to understand. Take a look again at this slide, how partition is being created. You have some servers. In this example, you have 7 servers within a single data center. Let's say it's all your cluster, 7 servers. Not so much, not so small, good fit. Now take a look. Every server is responsible for a set of partitions, for a set of tokens, range of tokens. And imagine you have one partition which is being used all the time, so everyone reads and writes to it, to this partition. It's being changed all the time, while other partitions are not really in use. What does that mean? It means what replication factor of your servers, let's say you have replication factor 3, so 3 of your servers will be busy all the time dispatching these queries, and other servers will be idling. And at some point, if load is too high, then these servers start choking because, well, they cannot handle all the queries, they're too busy, and other servers are still idling. And now imagine you are adding 100 nodes to this cluster. Doesn't matter. You can add 1,000 nodes to this cluster, still doesn't matter. Why? Because replication factor free, hot partition, you still have free servers dispatching those queries. And you can add as much servers as you want. You can add the whole AWS. It still will not help. That's a very important thing to consider. You do want to avoid hot partitions. So let's take a look at the first example. Primary key consists just of a user ID. User ID is the partition key and the whole primary key. It means what you have as much partitions as you have users. Perfectly fine. It's okay. Don't worry. It's good. You can have a lot of partitions. Then second situation, video ID created at comment ID. So we have comments stored by video. This example is operational at this point of a human history. As said, the biggest amount of comments per video is around 5 millions. So we can have partitions like that if they are small by the data, not so big. But imagine, history changes sometimes, and like let's start what all the Internet of Things now also start to write the comments. I don't know, crazy example, but let's imagine your phone or Alexa or your smartwatch also can make comments to the video. And when boom, we have like Internet of Things, we have much more smart devices than people. Even my washing machine is connected to the internet, seriously. If my washing machine will start write comments at YouTube, well, I don't know how to live after that, but still. And we have like not 5 millions of comments, but 500 millions of comments. And then obviously partitions are getting too big. You may say like, okay, your washing machine isn't going to write comments at YouTube. Don't worry, Alex. But well, get that as an example. Things may happen, things may change, and then you have already too big partitions, despite you haven't expected that. And obviously, the wrong example of the hot partition is the last example, then country and user ID. Imagine you're working in the e-commerce company selling some things in Europe, and all the countries in Europe are mostly not so big. And then you start to work with the countries in Asia like India or China, and you have really a lot of users there. And let's say you are very successful and you are very popular. People are buying your goods all the times. Congratulations, you got some money. But then you have obviously the situation I explained it above. Some of your servers will be overloaded while others will be idling. Like try to compare Luxembourg to China. Obviously server responsible for China will be overloaded. So splitting your clients by country may be definitely not the best idea. Now, we always have to specify the partition key. Why? As I said before, if there is a no partition key in a query, which node you will ask? You don't know, so you have to ask every node in the cluster. It's called full cluster scan. And you do want to avoid full cluster scan. As long as you have 3 servers, 5 servers, 7 servers, it's not so deadly. But the point is, cluster may look like that. Cluster may be even much bigger, so there can be literally thousands of nodes within your cluster. Which node you are going to ask? You have to ask every of them, and it will take ages. And you want your database, you want your Cassandra database to be able to dispatch data within milliseconds, even if you work with dozens of petabytes of data. So we must always specify the partition key. Take a look at this example. Table, users by city. City, last name, first name, address, email, all text. And then primary key, city, last name, first name, email, where city is the partition key. First query is wrong because I'm trying to load the data from users by city specifying only first name. I don't give a primary, I don't give a partition key. We don't know which server to ask. In the second example, I'm loading the data specifying the city and last name, and that's perfectly fine because, well, we specify the city, so we know which server to ask. And the first part is done. Eric, is there any questions you would like to answer, maybe?
No, I think so. I think we're good for now. I think people are understanding the bucketing. Um, and again, if you're stuck on the concepts of how the data gets distributed around the cluster, we really recommend that you need to watch the DS 201 videos at the Academy or for the DS 201 course.
Yep. In general, if those workshops pretty dense because it's hard to explain data modeling in 2 hours. It requires a little bit more time. So if you don't understand something at this point, do not worry, because the data model course at the Academy is a part of a homework. Sorry. So you will get everything after doing the homework. Now consider that as an overview. Okay, so let's move on to the example of how do we do data model from the very beginning. Let's start from the very beginning, a very good place to start. So, in comparison with relational data modeling, I will explain this part in comparison with relational data modeling because most of you have experience with relational databases. How do you usually create data model working with relational databases? First, you analyze the domain you are going to work with. So what kind of data we are having? What's the properties of this data? What should we handle? And in general, what we work with. And then we identify entities, their properties, and relations between them. In this example, I'm working with employees of a department and departments. So we can talk about enterprise resource management systems or just some employees management system maybe. An example on the right, you see we work with employees and departments. When we did identification for entities, properties, and relations, we can design tables for those entities using normalization and foreign keys. And when we are going to retrieve this data and work with we use joins when doing queries to join denormalized data from multiple tables. Designing tables and designing data model for relational database, we usually tend to use the normalization. What does that mean? Normalization is a structuring of a relational database in accordance with normal forms in order to reduce data redundancy and improve integrity. So, answer in general is very simple. You try to avoid data duplication. You try to store data in different tables. So, for example, as one department might have many employees, you have a list of departments, you have a list of employees, and then you make relations between them using foreign keys. So far, so good. And normalization is a great thing as long as you can afford it. Normalization makes your writes very simple and makes your data with a better integrity because database can take care of the integrity. And downsides of the normalization, slow reads and complex queries. Here is a question I usually ask, if maybe some of you know, how many of joins you may have in a single select statement in MySQL. Eric, do you know?
Ooh, is that like the question of life? Like, is that 42?
A little bit higher. The answer is in a single select statement in MySQL, you may have 61 join. And can you imagine this query? And can you imagine maintaining this query? So,
wow.
Yeah, in normalization, and I reached this limitation once, seriously. It was a bad day, really a bad day. So, simple write, data integrity. Downsides, slow reads and complex queries. A lot of joins. In comparison with normalization, denormalization is the opposite way to do the things. You duplicate your data and like the name of the department, in this case, stored both in the departments list, but also in the employees list, As one engineer may work in only a single department, let's say, one employee may work only in one department. Therefore, you simply have a field department per employee. And denormalization is also great, but it comes with some costs. Denormalization is a strategy used on a database to increase performance. In computing, denormalization is a process of trying to improve the read performance of a database at the expense of losing some write performance by adding redundant copies of data. Benefits of a denormalization: quick reads, simple queries. And negative side, well, multiple writes, and it's harder to maintain integrity.
And that's because storage is cheap, right? So
yeah.
the price per gigabyte is so low now that most people don't really care about the size of the disk. Most people care about latency. How fast can I get the data out of my database? So think about when you're doing like, 1 or 2 joins, it might take you, 500 milliseconds to do your query. But in Cassandra, when you want to be able to do things at scale, we know lots of organizations out there that have an SLA, for example, of 6 or 7 milliseconds per query.
Yep.
That's the reason that we denormalize.
Yes, exactly. So then, how do we go with NoSQL data modeling for Cassandra? It goes in the opposite way, exactly opposite like you do in the relational data modeling. In relational data modeling, you start thinking of data, then of models, then of application. For Cassandra, for NoSQL data modeling, it goes opposite way. People say think of your application, but I don't like this approach. I say think of your clients, users, customers, however they call them, but first think of the people. Don't think so much on the hardware, cold hardware. Think of the people. People, that's what's important. So first, analyze user behavior. Customer first. Think of what data they would retrieve or store to the database, what they want to do, not even thinking of a database, forget about the database, what's their purpose, what they are doing with your application. What do they want to achieve? Forget about the database at the first step. We identify workflows, their dependencies and needs. So we think of what people are going to do and what we want to achieve and what we will need to reach their goals. Then, based on the workflows we identified, we define queries to fulfill these workflows. And knowing the queries, we design tables using denormalization. And we use batch when inserting data instead of using join retrieving data. So we use batch when inserting or updating the normalized data of multiple tables. And I bet you are curious what the batch is. And I tell you, we explain it explicitly in the next workshop of this series. So stay tuned and join. Eric, who is doing the next workshop? It's Cedric, isn't he here?
Oh, it's
I think it's
probably
Cedric.
me, but yeah. So when you think of batches in Cassandra, it's not the same as batches in relational database. So be very, very careful about that. It's not to be used as an optimization because, in fact, if you try and use batches to thinking that it will make your writes faster, it's not going to work.
Yep. So good. And you maybe not understand the whole process right now, and it's very fine because now we work at the practical example. That's like talk is cheap, show me the code, and that's what we are going to do. Take a look at the example. That's a screenshot from our killer video application. What is a killer video? Well, that's an application we designed to overcome YouTube and become #1 video hosting in the world. Just kidding. No, that's a reference application we use to show how we work with Cassandra and DataStax Enterprise. But in general, that's a YouTube-like, so the same idea. Videos, users, comments. That's a screenshot of this application. And we are going to work with comments. And let's take a look at a couple of use cases we are going to cover in this example. Designing process step by step, and that's all you need to do to get a good data model. We define the conceptual data model and identify application workflow. We map them together to find out the things we have to do. Based on that, we create logical data model, then do physical optimization and define physical data model. Let's do it step by step. At the first step, we are thinking of things we are going to work. So we have to implement some use cases for comments, people commenting videos. We already have users, we already have videos, we now thinking of the comments. Conceptual data model for this workflow, for this use case is very simple. Every user has some properties like IDs, emails. Every video has some properties like ID, title, description. It's implemented already, and we think of the comment. Every user can write one or many comments to the video. Every comment may have only one author, and a video can have a lot of comments. User comments on video. Video is being commented on by user. And we work with application workflows. So what the use cases we are going to cover? There are 3 use cases we will cover, just to avoid too much of work for today. And first use case, user opens a video page. It means what we have to show comments for this video. And then workflow 1 sounds like find comments related to target video using its identifier most recent first. So we want to find comment for a video given we know video ID, but we don't know comment ID yet because, well, we have to retrieve them. We don't know their IDs. And use case 2 and use case 3 are very similar, so we merge them into one. A user opens a profile and we have to show his recent comments, so he or she can see amount of like likes or dislikes or something, answers maybe. And second use case, or well, third use case, moderator verifies a user if spammer or not. So for example, a user has been reported writing spam, and we want to check, I'm as a moderator want to check if he's spammer or not. I want to see all of his comments at once within the single query, within the single workflow on the one page without opening all of the videos he commented on, or she. So workflow 2 sounds find comments related to a target user using its identifier get most recent first. Notice the difference. In the first workflow, we find comments for a video given we have video ID. At the second workflow, we need to load the comments given we have user ID. In the relational database, it may be simpler, but don't forget we are designing a big data application working with any amounts of users, so we need a bit different approach. Then, yeah, Eric?
I was just going to say, Kajal Das raises a good point. So what if your application workflow changes or the application query, you've got a new application query? The basic tenet of data modeling is that every time you've got a new query, you have to design a brand new table for it. So yeah, so that's a very good point from Kajal Das.
Yeah, exactly. So good. Then based on the data we worked on, based on the application workflow and conceptual data model, we map them together and we start to talk about the queries. And query is everything in Cassandra. You must understand your queries to define a good data model. Query number 1 then looks like find comments posted for a user with a known ID, posted by a user with a known ID. Show most recent first. We think of comments by user. Query 2, find comments for a video with a known ID. Show most recent first. And that's about comments by video. And that's how our query finally look like. Select from comments by user, select all from comments by video, given we know video ID or user ID. And we start to think of two tables at the step of a logical data model. Comments by user, comments by video. Now, please stop for a moment and think. Why do we think of the two tables? Why cannot we have a single table for that? I told you everything you need to know to answer this question. I'm waiting for your answers at YouTube chat and hopefully Discord. Faster retrieval, good. Anything else? Sort order is different, faster read. It's correct, but there is a better answer. Partition key is different. Perfect. I see Saud Rahman answered it at YouTube, and my Discord got frozen, so I don't see if anyone answered it in Discord. Maybe. Sorry. So correct answer.
No, we're good.
Yeah, correct answer. Partition key is different. That's the correct answer. Partition key is different. Don't forget, as I told you in the very beginning. You always have to specify the partition key. And we know or user ID if you're retrieving a user comments, or video ID if we are retrieving a videos comment. But if you retrieve video ID, we don't know user ID. If we know user ID, we don't know video ID. And therefore, we cannot use, we need two tables because we will have two different partitions, two different partitionings. By user or by video. That's why we are having two tables, comment by user and comments by video. And well, in general, tables are looking very familiar, very the same. We have user ID or video ID as the partition key. We have creation date and comment ID as clustering columns. And video ID and comment by itself as data columns for the first one, and mostly the same for the second one. So they look very the same. And now, here is one great thing happens. One of the reasons I like Cassandra, some of the optimizations. Notice in the beginning, we have had 5 rows, 5 columns, 5 properties per table, but here we have 4. How come? How it happened? One of the data types of Cassandra I really like is time UUID. What does that mean? Have you seen UUID, Universally Unique ID, this long value of numbers, characters, making this number universally unique identifier. And time UUID is exactly the same, except of the thing it has time embedded into it. So it looks like UUID, but you can sort it and it will be sorting by time, and you can extract time out of it. So instead of 5 columns, now we have 4, user ID as a universally unique ID and comment ID as time UUID. So you have time and universally unique ID within the same column, and that's very convenient. Then video ID is also universally unique ID and comment is text. And second table looks also pretty close and looks very familiar. And then based off that, we already think about the definitions for this table. So we have create table.
If I could just quickly interrupt you, Alex. So we keep getting asked questions about Menti. We're not doing Menti right now. When we ask questions in Menti, it will actually flash on the screen. So at the moment, we are not doing Menti. So there is no Menti code. Forget Menti for now because nothing will show up on Menti.
Yeah.
Sorry, Alex.
No. Thank you. About the Menti, we are getting close to Menti, but the quiz is not started yet. So focus on the data model. Forget of the Menti. Menti is not the point. Data model is the point. Focus. Good. Then we think of the schema definitions. Create table, if not exist, comments by user, user ID, comment ID, video ID. Comment with primary key, partition key, user ID, clustering column, comment ID. With clustering, order by, comment ID, descending. So we will have latest first. And mostly the same for comments by video. Video ID, comment ID, user ID, comment. With primary key, video ID, comment ID, clustering order by, comment ID, descending. Ooh, we did a big work. And now we go to Menti. So Menti code for today, 719518. I repeat, 719518. And we go to Menti and we are going to answer questions. Sorry. Yes. Oh my God. Okay, it looks like my Menti woke up. And we can proceed. Connection lost. Reload. Okay, I need some time to reload my Menti, sorry. While I reload Menti, maybe you can answer a couple of questions, Eric?
Yeah, so we keep getting questions about materialized views. So yes, materialized views are a way of not having to do multiple tables. But at the moment, materialized views are experimental in Cassandra. We're working on them. So the community is working on improving it in 4.0 and beyond. But for now, you can run into problems by just using materialized views exclusively. So for now, we recommend that you denormalize your tables for now.
Yes, and my answer, my comment on the materialized views would be the main thing. Yes, it's experimental, so you can use materialized views. They are enabled, but there can be there is a flow which is not fully fixed yet. Then imagine you work with normal tables, and you are doing an insert query, and your data. And you have replication factor 3, and your query reached two nodes, but third node didn't get the update or insert. It means what you have inconsistency. 2 nodes are updated, one is not, but it's fine because Cassandra has a lot of self-defense and protection mechanism to defend itself from the inconsistency. So it will be fixed with read repair, or incremental repair, or whatever. It will be handled after some time. So you will anyway get your up-to-date data. Well, consider if you have proper consistency levels in your queries, of course, quorum, like we recommend. But with materialized views, it's different because there is no mechanism at this way to guarantee consistency between materialized view and base table. So for some use cases, materialized view can be a good approach, working with data of a secondary importance, let's say. But in general, it's experimental, and we recommend to be careful with materialized views. I know some success stories about materialized views. I know some not success stories with materialized views.
So are we ready with Menti?
I think so. Let's go. And we are ready to start. Hopefully.
So it looks good to me. So let's try and do it on your mobile phone, because speed is
we are getting first question already. A key space is organized into rows in columns, contains tables and sets replication, is a base unit of access, is a place to store extra house keys. Well, I'm very curious how people will answer today. Time is up, and let's see. Yes, key space contain tables and sets replication, and that's very correct answer. Some people have answered is organized into rows and columns. No, key space is not organized into rows and columns, but it's a container for tables. And some people say that key space is a base unit of access. Well, it's not a base unit of access. It's a container for tables. And let's take a look at the leaderboard. Okay, I see some familiar names. People don't cheat. And congrats, Barefoot Contessa. I remember you were here yesterday. Glad to see you again. Vaibhav Gupta, second name with a very good time of answer. And Abhishek Srivastava, third place, shares third place with Loveside. Okay, great. So let's go. Next question. We have 6 more, so just the beginning. In Cassandra tables, which are required? Data columns, clustering columns, partition keys.
And while we wait, so if you're having trouble with Menti, it's easier if you do it on your phone rather than on your laptop, because it's a lot faster.
Yep. And it may be good to install Menti application on your mobile phone because, well, it may work better than browser. We will do Menti again.
And don't look at the stream because the stream is a little bit delayed compared to Menti. Menti is live on your phone.
Yep. So in Cassandra tables, which are required? Partition keys are required. We must always specify the partition keys. It's not possible. And clustering columns and data columns are optional. Required are partition keys. Leaderboard may have changed now. And how it looks after the update. Vijay Kodam got the first place with the fastest and correct answer. Pingu getting the second place, and Pani getting the third place. Take a look, it's completely changed after one question. Let's move on. Yeah, in Cassandra, tables hold 1 or more partitions, only rows and columns, replication factors, endless sea of hopes and dreams. Yes, I think that's the correct answer. Code for Menti is 799518 as it's specified on the screen.
So it's at the top of the screen right there.
And I see. Yes, table hold 1 or more partitions. And a lot of people answer it only rows and columns. And nope, table is the first thing. First thing in the table is a partitions. And answer only rows and columns is not correct, sorry. And replication factor, no. Key space stores replication factor. Key space defines replication factor, not table. So, how the leaderboard will look like after this question? Okay. Akshay BE is the fastest one. Congratulations. Pingu is holding second place, but the third place is taken by Tarun M. Congrats. So, take a look. It changes every question now. In Cassandra, a partition is a group of columns, base unit of access, defined by clustering columns, or a physical barrier between spaces. Be careful, it may be a trick. Be careful with this answer. 。 . 。 . 。 . 。 . . 。 . . . . . . . 。 . . . . . . . . 。 . . . 。 . 。 . 。 . 。 . 。 . . 。 . 。 . 。 . 。 . 。 . 。 . . 。 . . 。 And the correct answer, partition is the base unit of access. Partition is not a group of columns, and partition is not defined by clustering columns. Clustering column defined by primary key, but partition is defined by partition key. And partition is the base unit of access. You always have to think of it as the base unit of access. And well, it's not a group of columns, it's a group of rows. Okay, so what's the leaderboard now? So maybe you got some changes in the leaderboard. Okay, and how it will look now? Tarun M raises from the 3rd place to the 1st place. Very nice. And Pingu holds the 2nd place. Smart move, because 3 winners, 1st, 2nd, and 3rd place will get the prizes. And the 3rd place is taken by Pani. Okay, let's move on. In Cassandra, a partition key is a row to identify the partition, must be unique and identifies a row, a value of a columns to calculate a token. Well, and the key to open any data center door, I would like to have one. So 5 more seconds. 3, 2, 1, time is up. And the correct answer is, partition key is a value of a column to calculate a token. Must be unique and identifies a row. That's a primary key, not the partition key. Uniqueness is the function of the primary key. And partition key is not a row to identify the partition, but more a column value to identify the partition, but not a row. Okay, so how our leaderboard will look like after this one. Okay, very interesting. Okay, Tarun M keeps the 1st place, congrats. Pani 2nd place, and Radulini got the 3rd one. Very good. And we are getting very close to the end, so just a couple of more questions. How does Cassandra perform joins? Cassandra joins require a join table. Just like SQL joins, Cassandra does not support joins. Cassandra only joins clubs. More and more people are answering. Five, 4, 3, 2, 1, over. Time is up. How does Cassandra perform joins? Cassandra does not support joins. Correct answer is Cassandra does not support joins. 49% answered just like SQL joins. Hey everyone, please focus. That's not a correct answer. There are no foreign keys and no joins in Cassandra. So, leaderboard. Will you surprise me this time? Okay, so not so much changes this time. Tarun M keeps the 1st place. Radulini got the 2nd one. And it was the fastest answer of all the people participating in the quiz. And Pani lost to the 3rd place, but not a big deal because, well, 3rd place also got the prize. And Cassandra, data modeling, you model your data with normal forms. Start with your application workflows. Start by creating fact tables. What's your answer would be? No.
So what is the right side of the catwalk? Is it the left side or the right?
I don't know. I have to ask my cat. Well, I don't have a cat, so I will have no answer, I guess. Time is up. And the correct answer is start with your application workflows. Very right. And model your data with normal forms. No, in Cassandra, we go with denormalization, and therefore we don't tend to use normal forms. And the leaderboard is about to not so much changes. And the winner is Tarun M. Congratulations, Tarun M. First place, very great job. No wrong answers and very, very quick. Radulini gets the second place and Pani gets the third place. Congratulations, very well done. I also congratulate Puggy. Answer was the fastest for this question, but it was not enough to get to the first three places. So, winners, please contact Jack Fryer at our Discord server and talk with him how you will get your prizes. We will send them by mail. Please, sorry if there are any delays because, well, with the given situation in the world, some packets travel not as fast as we would like to, but we will dispatch everything very soon. And also, please write in the chat, where are you from? It's very interesting, and we can congratulate you then in the chat with our winners. Good. So, let's go. Our next topic is data types. Data types is a very interesting topic because, well, that's important to know how you store your data and how you work with the data. And well, I don't want to speak too much about the basic data types because basically you know all of them or you have met most of them in other databases. So things like Boolean or integer, things like that, those are very familiar to everyone. What's also can be useful for you, or maybe not in every database, you may have innet type. Innet means an IP address, either version 4 or version 6. So it may be handy when you work with internet addresses. T-type, I've explained it to you already, time UUID. It's a great hybrid of universally unique ID and timestamp. So you can handle it as both universally unique ID and time. But in general, all the types should look very familiar to you and pretty understandable, like timestamp, for example, or varchar, and so on. Let's get to more interesting topics. Collections. Collection, there are three kinds of collections. You can store a lot of things within the same cell: set, list, and map. Set is a set of unordered things. It doesn't care about the order. List is the same as set, but it cares of the order, so it keeps the order you insert the values. And map is the associative array, let's say, so you have key value pairs. How set works? Very simple. You can define it as set and specify the type of this set. So in this case, I'm using set type text. I'm going to store text. And that's I'm going to work with text. So in our killer video application, we have videos, and every video may have text. No one cares about the order, talking about the text, because, well, the order is not important for text. And on the right, you may see the examples. Like it's a killer video, we speak about the videos. What you can do with the set? Obviously, you can insert set. So insert into videos, video ID text, you specify video ID, you specify text, just like JSON format should be very familiar to you. You can update set and set it new, so replace the entire set. Very easy. Also, you can add to set. So you can just plus something and you have it added to set. List is mostly the same, except of the order. So we have in this same key space killer video, table actors by video, and we have actors list type text. So it will be obviously their text names. You can insert list. So like we do in the first example, actors by video, video ID actors, and specifying in this case Adams, Baker, Cox. You can replace entire list if you want. So just write a new list instead of the old one. And you can append list, adding something to it in the end, for example, like in this example, actors plus Crawford. You can also replace an element knowing the order. You can specify, in this case, update actors by video, set actors num position 1 to be equals brown. So obviously it will overwrite the previous value of this position. Collection map. Map is a very simple concept. Then you're creating table, like in this case, we will store phone numbers. Every person may have multiple phone numbers like home, work, mobile phone, maybe something else. So you may want to store phone numbers in a map. And in this case, we have map type text. First field specifies the type of the key. Second field specifies the type of the value. In this case, key will be text and value will be text. So what we can do with the collection type map? We can insert everything. So in this case, we define a mobile number, for home number, and business phone number. For the user ID, we can replace entire map, just overwrite it completely. Or we can append to a map, like in this case, we are adding desk, phone number, whatever it means. And we have that arranged here. Now, this is a cool thing. That's a user-defined types.
Before you move on, Alex, so we've got a really good question here. So question was, what is the maximum amount of items that you can store in a collection? So depending on which type of collection it is, but generally it's 64,000. But we tell you not to go anywhere near that. It's really designed for storing a small amount of like for like data. If you have to store thousands and thousands of items in a collection, you might need to rethink. Maybe you need to define it as a table, like create a table instead with different columns in it.
Yep. And you know what? Erick answers questions all the time. That's his super skill. And if he chosen your question to answer, it means you have asked it a very good question. Good. So, user-defined types. Those are important, and that's a very convenient thing to use. You can create your own type. That's cool because, well, you definitely may find a good use for that in your applications. In this case, we create a type address having street, city, and state, all of the type text. And then you can use this type in your tables exactly as you use any another base types, for example, or collections. So, and that's important to understand. Type, user-defined type, or UDT, that's like a common abbreviation for the user-defined types. UDT is defined per key space. So if you work with multiple key space and you want to have those user-defined types in every key space, you have to create it for every key space you are working with. Then, and you see we create a table in the second example, killer video users, having user ID and location. And location is type of address we just created. And what can we do with user-defined types? We can insert them, like specifying the street, city, state. We can replace the entire UDT, overwriting it, or we can update one single UDT field and take a look how it's done. Looks very convenient to me. Update killer video users, set location city equals Albany in this case, so someone has moved. The user ID is. So you can replace, you can work with this fields directly. And interesting point, you also can load some values directly without loading the whole UDT or whole row. Just select location point city from killer video users. Counters. Those are interesting.
So just really quickly,
Yeah.
Alex, so one of the questions that keeps coming up is, why would you use a UDT?
You want me to answer?
Yeah. Why,
okay.
why would you use a user
Come on,
type?
answering questions.
It's a native type.
Answering questions is your job. No, just kidding, of course. So, well, in general, it defines on your use case. Take a look. You can go with map. You can go with regular columns. But in some cases, UDT may be a more convenient way to approach. It's hard to answer without knowing your use case. But in many situations, this way may be just more convenient to store and retrieve data.
Yeah, so personally, I wouldn't use a UDT if I can use native types. People think, some users think that based on their use case, it's a lot more convenient to have their own type that they create. That's fine, but if you can do it natively, it's always the best way of doing it.
Very good question in YouTube chat. Kajal does. Can a list or set or map of UDTs be created? Yes, it can. There are possibility to create nested types, and that's pretty convenient. So let's get to counters, and we are very close to the end. Counters is a 64-bit signed integer used for imprecise values such as likes, views, etc. It supports only two operations, increment and decrement. First operation assumes the value is 0. That's usually this counter type, advanced data type, is the type when people start to ask questions. So what's that they use it for? It uses it to very quickly update integer values and counts likes, views, and all the things like that. And notice the word imprecise. It means what you don't want your bank to use counter to work with your money, seriously. That's more for things like views or likes at YouTube or, I don't know, Facebook, but not for precise values you want to be precise. But very quick and very convenient in many cases. Important limitations about the counters. Counter cannot be part of a primary key or especially partition key. Can you imagine a partition changing its token all the time? It will just lead to very bad consequences. Counters not mixed with other types in table. So if you have a table with a counter, you may have there more counters, but you don't want to have the integers or text or things like that. Value cannot be set explicitly, but you can specify the amount of increment or decrement, so it works mostly the same. Rows updates are not idempotent. It's important to understand what idempotent thing is something like set username equals, I don't know, John. So how many times you repeat this operation, it will still, then the username will still be equal John because that's idempotent operation. Updates of counters are not idempotent. So if you make +1 and repeat this operation a few times, value obviously will be increased few times. Again, counters should not be used for precise values. How do you use counters? Okay, create table video playback stats, a video ID, universal unique ID, obviously that's an identifier for the video, and then views, a counter, and then you can work with this counter, increasing or decreasing that. Well, usually views are only increasing. And you may want to add one more counter type into this table. So it may be video ID, views, and likes. and dislikes. So you may have free, for example, free fields here, 2 counters, but you cannot add any text column or any integer column. And operation with counters are pretty simple. You update killer videos, set views equals views plus 1, so increment, or you can decrement the counter, set view minus 1. Just change the sign. And that's all with advanced data types, and we were very quick, so we are perfectly on time. Eric, anything you would like to add?
Yeah, so just with that, the concept of idempotent. So in this example where you're doing a set views equals views plus 1, so you're trying to increment the counter. If for whatever reason that query fails and you do a retry, you don't know whether let's say you got a timeout. You don't know whether your previous increment worked or not. And then if you increment it again, you end up incrementing it twice. And so that's why, you got to be aware of the dangers, particularly in a distributed environment. Counters are very difficult to implement. It's not like where you're running, say, on Oracle, where, the storage is shared and, everything is shared even in the rack configuration.
Mm-hmm. Yep, exactly. And we are done for today. There are just to discuss few next things you have to do. But before doing that, I want to answer, I want not to answer, but I want to highlight 2 persons answering hard in the YouTube chat. I really want to thank you, Jeremy and Alice. Jeremy and Alice are great experts in the Cassandra, like with, I don't know how many of years of experience you have, but that's incredible to have so great specialists answering questions in YouTube chat. So
and Yoshi, Jeremy, let's not forget Yoshi.
Yoshi, yeah, as well. Thank you so much. I'm watching the chat and I see all the time. Alice Latini, Geromatron. Alice Latini, Geromatron. But yes, Yoshi was answering as well. Thank you so much, everyone, for the team spending your time and answering those questions here. It's really great. And we are very happy to see you here. And our attendees are very lucky to have you here. Thank you, friends. Okay. So, let's move on. We have to discuss some things we are going to do next. So first, homework, Hausaufgabe, just 3 points. Do notebooks. Those are 2 notebooks, data modeling and advanced data types. They're stored at our github.com DataStax Academy Cassandra Workshop series, week 2, notebooks. And well, that's important. So you just load them to your Astra account, DataStax Studio at your Astra, and do the steps. If you have any questions, use community.datastax.com. It's the easiest way to reach Eric. Eric, does your relatives or friends also use community DataStax to reach you, or they prefer phone?
Yeah, tell them not to text me. Just ask a question on community. I'll answer quicker if they post on community.
Yeah, indeed. Okay. Then watch the DS220 course, only videos without the exercises. And if you haven't watched the previous course, 201, you also have to watch it. That's a homework from the previous week. And that's important. I'm monitoring the questions at YouTube. I see really a lot of people asking questions of the content of week 1. If you want to be successful with Cassandra, you have to get this content very good. So watch the week 1. Don't forget about that. And then validate your participation, fill the form. It's just 5 short questions. If you did the homework and attended the workshop, it will be really easy for you. But if you want to have more, first of all, we are very happy you wanting to have even more. We have a bonus, which is optional, but, well, recommended, of course. There are some scenarios in Katacoda. Very great project when you can go and do the interactive course directly in your browser. There are Cassandra intro course, and there are scenarios you may consider for this week. Single row partition scenario, multi-row partition scenario, advanced data types. That's a bonus content for this week if you have more time than others or more desire to do more work. Course you did already, DS201 Foundations of Apache Cassandra, and if you didn't, you should. And course for this week, DS220 Practical Application Data Modeling with Apache Cassandra. Resources you may need. Join academy.datastacks.com. There are also some interesting content at datastacks.com/dev. Ask Share at community.datastacks.com. Make Erick happy, ask him questions.
And Bettina.
And Bettina, of course. Join community.datastacks.com, and we have a special space there for the Cassandra Workshop series, Cloud Native Workshop series, available there. Follow us at YouTube. You see there is a subscribe button. If you haven't subscribed on us on YouTube, you have to do it right now. Consider it as a part of a homework.
Hit the subscribe button, please, right under me.
Yep.
Do it now.
Then Twitter, and if you prefer Twitch, we are on Twitch as well, and Discord server, of course. And materials for all the course are available at the DataStacks Academy Cassandra Workshop series at github.com. Congratulations! You did 2 weeks of our workshops, getting started with Cassandra and data modeling. Well done. Next week, we start to write real code, and it will be application development with Cassandra part 1. How to build applications with Cassandra. There are 2 possible workshops for you to join, on Wednesday or on Thursday. Notice content is the same, so just choose the workshop which's timing is better for you. Wednesday or Thursday, and they are for different time zones, because we are, as Cassandra does, we are globally available, and we work for different time zones and regions and countries. So pick the best one for you. And in the second part, later, we will work with testing, deploying, and monitoring applications. Thank you. It was great to have you all here, and thank you for great questions.
Thanks very much. There's people posting all the links now. So there's one link, and in that link are all the links you'll need for the workshop.
Yes. So it was Erick RAMIREZ from Australia, Aleksander VOLOCHNEV from Germany, and we are really happy to see you here, answer your questions, and see you soon at Discord or community.datastacks.com. Every next workshop makes you a stronger and better developer. So that's amazing.
Thanks for joining us. We'll see you next week.
See you next week.
Imagine a being gifted with powers from the goddess of Cassandra, who grew those powers until she could multiply at will, move with limitless speed, and unmask hidden knowledge. With those powers, she was able to fully understand the connectedness of the world. What she saw was a world in need of understanding. From that day forward, she sought to bestow her powers on all who came into contact with her, empowering them to achieve wondrous feats. Imagine a being gifted with powers from the goddess of Cassandra, who grew those powers until she could multiply at will, move with limitless speed, and unmask hidden knowledge. With those powers, she was able to fully understand the connectedness of the world. What she saw